we've moved from finding the volume of cylinders to now we're going to find volumes of cones. The one thing I want you to sketch for sure is this cone in your notebook. A cone is really has a base, and then it meets at top at a point called the apex. So the height will always connect. The height will always connect the base to the top. Okay, that's just a simple definition of what the height is. The base will always be the length segment that connects the base to the top. So what do we know right now? We also know that there is a formula for finding the volume of a cone. And in class, we've gone through finding the volume of a cylinder. The volume, and just to review real quick, the volume of cylinder is pi r squared times height. It's pretty simple. This is the area of a circle times its height. Remember we talked about without depth, without height, it's a two-dimensional shape. When you add height, you give it volume. The cool thing about a cone that I'm going to demonstrate later in class Y is if a cone and a cylinder have the same base or the same radius, then it is by definition very similar, and actually 3 times. 3 cones can actually fit within one cylinder if they have the same circumference and area. It's pretty cool how it works. So therefore, this is the volume of a cone. The volume of a cone is pi r squared times the height divided by 3, or you can do volume of a cone is equal to pi r squared h, but multiplied by a third. Now multiplying by a third and dividing by 3 are exactly the same thing. Okay? Make sure you guys pause it and write it down if you must. And then we also have the volume of a pyramid. This is a rectangular pyramid. We name pyramids by its base. Capital B. Capital B will be area of a base. So we'll use a capital B for a circle. The base will be a circle, so you do pi r squared. This case, this is a rectangular pyramid, so you would do the area length times width, and that would be the area of the base, and multiply by its height. So capital B will always be area of the base, and then height is the one that connects the base to the top or the 2 bases. We also know that in a rectangular pyramid, one rectangular pyramid will also fit in a rectangular prism 3 times. That's why we divide by 3. Make sure you have that formula down and this picture. Pause it if you must, and then copy it down. Okay, let's get into it. So let's do the first one, finding the volume of this rectangular pyramid. First thing I always do is write down the volume of the area of the base. This is a rectangle, so you know that the area of this would be 5 by 3, 5 centimeters times 3 centimeters. This is the same as your capital B. So right now we have volume is equal to 5 centimeters times 3 centimeters times the height. The height connects the base to the top, which is 6 centimeters. So here we have volume is, do your orders operations, 5 times 3 is 15 centimeters times 6 centimeters. The volume here is going to be 9 centimeters cubed. Now this is the new one. The reason why it is to the power of 3 is you're multiplying 1 centimeters, 2 centimeters, 3 centimeters. You see 3 centimeters being multiplied, that is going to be to the power of 3. So my answer here is the volume is 90 centimeters cubed. Give you guys a chance to copy this down. Okay, moving on. Next we have the volume of a cone. Here's the formula. Again, the volume. This is the same thing as saying capital B. Whenever you see capital B in geometry, for this case, it will be the area of the base. Here, pi r squared. The base here is the circle, so the first thing we want to do is find the area of the circle and then multiply by how tall it is. So the area of a circle, so we know that we also will have 2 answers. the exact and the approximate, because we're dealing with pi. So let's do the exact first. So we have area is equal to pi r squared. And then to get the volume, we need to do pi r squared h divided by 3. So let's find the area of the circle first. So the radius is going to be pi times, the area is going to be pi times radius squared. So the area is going to be 25 pi. Now let's bring it down to volume. So we'll put this in for this right here. So volume is equal to 25 pi times the height. Volume is equal to 25 pi times 8. And then we have volume is equal to 200, because we're multiplying these two numbers. 200 pi. So all I did was first thing I do is find the area of the circle, that is base. It's pi r squared, so in this case it's 25 squared times pi, which is 25 pi. I went ahead and substitute that into the formula. Times its height, I get 200 pi. Next, I need to divide by 3. And you can technically, since we're doing exact, you can leave it as is, because if you don't want a decimal, you can technically do 200 divided by 3, which is 66.6 repeating pi, in this case, units cubed. Either one would work. And then to find approximation, you take 200 pi thirds, and you would replace the pi symbol with 3.14, and you multiply those together and then divide by 3. Okay, orders operation tells me I need to do what's in my numerator first. So 200 times 3.14 equals 628 divided by 3. We're going to divide by 3 last. We get volume is equal to approximately 209.3 repeating units cubed. And that's how you find the volume of this cone. It's either going to be 66.6 repeating pi, it could be 200 pi divided by 3, either one would work, or approximation would be 209.3 repeating units cubed. All three answers exactly the same. This is exact form, this is approximation. The only difference now is finding the volume of a cone is similar to finding the volume of a cylinder, pi r squared times h, but this time you have to divide by 3 because one cone is a third of a cylinder. Okay, question that we're going to go over in class. How are the volumes of a cone and a cylinder related? Just think about that, ponder it. How are they the same? How are they different? Does it matter? And then we'll go over in class. So make sure you guys going to have to rewatch this a couple times to get the hang of the formula, just like we did in class, and then we'll whisk it in class. Okay? All right?